First step, we have to introduce slack variables. There is 3 subject to the constant, so we have to introduce 3 slack variables that are s1, s2, s3 in the constants of the given LPP. Okay, which is a problem we have to find optimal solutions. So we have, let's begin. Here maximum z is equal to, we have to find standard form. Maximum z is equal to 3x1 plus 5x2 plus 0 into s1 plus 0 into s2 plus 0 into s3. Subject to the constants, x1 plus s1 is equal to 4, x2 plus s2 is equal to 6, 3x1 plus 2x2 plus s3 is equal to 18, where x1 comma x2 comma s1 comma s2 comma s3 all are greater than or equal to 0. Next we have to find IBFS, initial basic feasible solution, by putting x1 is equal to 0, x2 is equal to 0 in the substitute the constants. Then we get s1 is equal to 4, s2 is equal to 6, s3 is equal to 18. Next step, we have to find initial simplex table. I only draw for perfectly one diagram, one table. After that I have to write simply. See, x1, x2, s1, s2, s3. Cost coefficients of objective function are 3, 5, 0, 0, 0. Basic solutions, basic variables, that is introduce slack variables s1, s2, s3, their cost coefficients in the objective function 0, 0, 0, requirement values 4, 6, 18, cost coefficients of subject to the constants with respect to x1, x2, s1, s2, x1 1, x2 0, x1 1 remaining all zeros, x1 0, x2 1, 0, 1, 0, 3, 2, 0, 0, 1. We have to find ZJ value by multiplying ZJ is equal to CB into XJK, CB into XJK, that is with respect to multiply 0 we get all values are 0. Next we have to find Cj minus Zj is less than or equal to 0. We get 3 5 0 0 0. 5 is the key column. We have to find key row by using theta is equal to minimum of b by x2, where x2 is greater than 0. Then we get 4 by 0. Take this column. We will not take 6 by 1 is equal to 6. 18 by 2 is equal to 9, which is the key row. 1 is the key element. Entering vector, leaving variable s2. Key element is equal to 1. Okay, next we have to go to iteration table 1. Iteration 1, Cj, Cb, Xb, B, X1, X2, S1, S2, S3, 3 5 0 0 0. S1 is as it is. Entering vector, that is x2, s3. Cost coefficients 0, x2, 5. Then we have to find key element is equal to 1. We have to write as it is. 6 0 1 0 1 0. The 0 in the key key column, the new variable that also 0, then we can write as it is 4 1 0 1 0 0. S1 1 remaining 0, S2 S2 1 remaining 0, S3 S3 1 remaining 0, which is a simple trick we have to use every time. Now we have to find new variables for remaining ones. X3, that is 18, minus corresponding key column value, that is 2, into corresponding new key row value 6. 18 minus 2 6, that is 6, and we have to old value 3 minus corresponding key column value, that is 2 into 0, we get 3. Here 0 minus 2 into 1, we get minus 2. Then we have to find ZJ. Two values become 0, to only 5, 5 0 0, 5 1 is 5, 5 0 0, 5 1 is 5 0. Next we have to find ZJ minus CJ is less than or equal to 0, we get 3 0 0 minus 5 0. Then 3 is the key row, and we have to find key 3 is key column element. We have to find key row, which is the key column vector theta is equal to minimum of b by x1, where x1 is greater than 0, and 4 by 1 is equal to 4. 6 by 0 we don't consider. 6 by 3 is equal to 2, which is the least value, minimum value. So we take the key row. 3 is the key element, x1 is the entering vector, s3 is the leaving variable. Then we have to go to iteration 2, that is cj cb xb b x1 x2 s1 s2 s3. Their values, cost coefficient values in object function 3 5 0 0 0. S1 as it is x2, the new entering vector, that is x1 0 5 3. Then we make key element which is equal to 3. We want 1 every time. For the new iteration table we have to convert key element into 1. So for this 3 value we get divide entire row by 3, then we get 2 1 0 0 minus 2 by 3 1 by 3. So is already 0, we have to write as it is 6 0 1 0 1 0. x1 x1 1 remaining 0, s2 s2 1 remaining 0, s1 1 remaining 0. Then we have to find new variables for remaining ones, that is s1 whole value 4 minus corresponding key column value 1 into corresponding new key row value, that is 2. 4 minus 2 we get 2. s2 0 minus 1 into corresponding new key row value, that is minus 2 by 3, we get 2 by 3. Simply we get minus 1 by 3. Okay, then we have to find zj value, that is 3 5 0. 5 plus minus 2, that is 3, that is 1. We find cj minus zj value, that is less than or equal to 0. We get 0 0 0 minus 3 minus 1. The condition is satisfied, that is equal to 0 equal to 0 equal to 0, less than 0 less than 0. So we get optimal solution for the first objective function. Before changing the cost coefficient, we get optimal solutions, that are optimal solutions of x1 is equal to 2, x2 is equal to 6, s1 is equal to 2, s2 is equal to 0, s3 is equal to 0. Then we get maximum z is equal to 3x1 plus 5x2. We substitute 3 into 2, 6 plus 5 6 is 30. Then we get to maximum z value is equal to 36. The optimal solutions of the given LPP of in maximum z is equal to 36. Then we have to check one substitute the constant, that is x1 plus s1 is equal to 4. Here x1 is equal to 2 plus s1 is equal to 2 equal to 4 is satisfied. So which is what we have done in the above process, which is right. Then we go to next part, that is changing the cost coefficient in objective function, that is maximum z 3x1 plus 5x2 changing into 3x1 plus x2. So which is cost coefficient of x2, that is c2 into 1. Okay, we have to find, this is a part 2, which is an important step. So every time we have to find, first of all we have to write one formula, that is maximum of xj is greater than 0, that is mod zj minus cj by x2j, because we have to change the c2, that is second cost coefficient. So we have to take x2 is less than or equal to delta c2 is less than or equal to minimum of xj is less than or equal to 0, that is minus zj minus cj by x2j, which is the required formula. We have to check for non-basic variables only. We have values, that is a simple trick. I have to use cj minus zj. So we have to want zj minus cj is greater than 0. Then we have to multiply the negative value 0 0 0, we get here positive values for Zj minus Cj values. So one trick is there, that is C2 star is equal to C2 plus delta C2. We have to find delta C2 values also. That is delta C2 is equal to C2 star minus C2. Okay. And substitute the maximum of x is greater than 0, that is Zj maximum Zj Cj value, that is 3. We get minus of 3 by x2j. That is the positive value x2j. We take 1, that is delta C2 less than minimum of xj less than or equal to 0, that is least value, that is 1 minus then x2j, that is 0. That is minus 3 less than equal to delta C2 less than equal to 8. Okay. So we want delta C2, then we have to add old C2 value to this equation. We get 5 minus 3 delta C2 plus delta C2 plus 5 less than equal to 5 plus infinity. We get 2 delta C2 less than or equal to infinity. So we know C2 star, that is a new variable. So the new cost coefficient, that is the value is 1. So we have to check 2 is less than or equal to 1 is less than or equal to 8. So which is not satisfied. If the new changed cost coefficient value in the objective function is in between these limits, we have to stop, and as it is we have to write the same optimal solutions for these also, but this is not satisfied. Then we have to proceed to next iteration table. There is iteration 3. So we have to write Cj, Cb, Xb, B, X1, X2, S1, S2, S3. X1 is S3. For new cost coefficient in the objective function, change it to 1, remaining 0. We have to write this table same as to this table. Instead of, we have to take 1 in place of 5 only, cost coefficient only, as it is remaining are same. So then I write S1, X2, X1, 3, 1, 6, 2, 2, 0, 1, sorry, 0, 0, 1, 2 by 3, minus 1 by 3, 0, 1, 0, 1, 0, 1, 0, 0, minus 2 by 3, 1 by 3. After that, we have to find ZG value, that is 3, 1, 0, 1 minus 2, that is minus 1, 1. Cj minus Zj is less than or equal to 0. We get 0, 0, 0, 1, minus 1. So 1 is the key column value, which is the key column vector. We have to find theta is equal to minimum of b by s2, where s2 is greater than 0, that is 6 divided by 2 by 3, 2 by 1, 2 divided by minus we do not consider. Okay, only we consider positive values only, because s2 is greater than 0, but it minus s2 is less than 0, so we have to consider these two values only. Actually something is here, s1 is equal to 2, x2 is equal to 6. S1 is equal to 2, S2 is equal to 6. Okay, so then 2 divided by 2 by 3, 6 divided by 1, here 1. Next 2 divided by 3, then we get 3. So 1 is the key element, which is the key row. S2 is the entering vector, x2 is a living variable. Actually we have done big mistake, that is so I have to write one time 2 by 3, 1 minus 2 by 3, here 1. So 6 by 1 divided by we get 6. So which is the minimum value? That is key row. So this is the key column vector. 2 by 3 is the key element. S2 is the entering vector. S1 is the living variable. Iteration 4. Cj, Cb, Xb, B, X1, X2, S1, S2, S3, 3, 1, 0, 0, 0. That is new variable, entering variable s2, x2, x1, 0, 1, 3. So we have to convert key element into 1 by multiplied into 3 by 2 total row. Then we get 2 into 3 by 2, we get 3, 0, 0, 3 by 2, 1, minus 1 by 2. Next x2, x2, 1 remaining 0, s1, 1 remaining 0, s2, 2 remaining 0. We have to find these remaining values. Okay. That is 6 minus 1 into 3, we get 2. We get 3. What happened? So next 0 minus 1 into 3 by 2 minus 3 by 2, 0 minus 1 into minus 1 by 3, we get a positive 1 by 3. Then we get 2 minus 2 by 3 into 3, we get 2 plus 2 is equal to 4. Then 0 minus 2 by 3 into 3 by 2, then we get 1. Here we get 0. Then we have to find ZJ value. 3, 1 minus 3 by 2 plus 3, that is 3 by 2, 0, 1. I think we have to check once for this. 0 minus 1 into minus 1 by 2, we get positive 1 by 2. So actually is not 1 by 3, to write 1 by 2. So then it is 1 by 2. Then Cj minus Zj less than or equal to 0, we get 0, 0, minus 3 by 2, 0, minus 1 by 2. This condition is satisfied, is less than 0, equal to 0, less than 0. Then we have to stop the iteration. Then finally we get to optimum solutions for the new objective function changed to 3x1 plus 5x2 is changed to 3x1 plus x2. So we get x1 is equal to 4, x2 is equal to 3, s2 is equal to 3, s1 is equal to 0, s3 is equal to 0. Then maximum z is equal to 3x1 plus x2. 3 4 is 12 plus 3 is equal to 15. Here maximum z is equal to 15. We have to check subject to the constants. First one, x1 plus s1 is equal to 4. x1 is equal to 4 plus 0 is equal to 4, satisfied. Second one, x2 plus s2 is equal to 6. x2 is equal to how much? 3 plus 3 is equal to 6. Satisfied. Third substitute the constant. 3x1 plus 2x2 plus s3 is equal to 18. 3 4 ja 12 plus x2 value 3 ja 6 plus 0, then we get 18 is equal to 18. Satisfied. We get the optimal solutions for the new cost coefficient change in the objective function, that is x1 is equal to 4, x2 is equal to 3 are the optimal solutions. Okay, thank you for watching this. Please watch my videos in 1.5x because I am solving problem in live, so it's take too much time to solving. That's why you have to watch in 1.5x. If you better, you watch in 2x. Okay, thank you guys.